Hello, this is The Intelligence. In the previous video, we talked about three combinatorial notations, which are factorial, permutation, and combination. And I don't know if someone remembered that I said we have to understand the three notations in two ways. We have to understand both their algebraic meaning and combinatorial meaning. In the previous video, we talked about their algebraic meanings, which means we learned the way to calculate the three notations. So today, we're going to focus on their combinatorial meaning, which means how do we apply the three notations in a counting question. First, let's talk about factorial. Now I'm going to give you a situation. Imagine that I have n students. Of course, every student is different, because we know that there are no two persons in the world are the same. And now, I want the n students to line up. And I'm interested in a number of ways for the n students to line up. So first, let's have a specific example for us to understand the question better. That means I'm gonna give a specific value for the number of students, n, first. Let's say I have 3 students this time, who are student A, student B, and student C. Since I want the 3 people to line up, I need to prepare 3 places for the 3 students. So here I'm going to draw 3 places. For the first place, I'm going to have A, B, C, 3 person choices. For the second place, I'm going to have 2, because 1 is already chosen for my first place. And of course, for the same reason, for the last place, I'm just going to have 1 choice left. To finish up this question, we need to apply multiplication principle and multiply the 3 numbers together. If you're confused why we use multiplication here, you should go back to the multiplication principle, that video, and check it out. Okay, so for the specific example when n is 3, we can solve it by multiplying 3 and 2 and 1. So now, let's consider the general situation, which n is just n. It can be any positive integer. So what I'm doing here is try to deduce a general formula for any positive integer n. Same thing here, I have n people, so I'm going to prepare n places for the n people. Let's just name them 1, 2, 3, and n. For my place 1, I have n people, so I have n choices. For the second place, 1 is taken from my place 1, so I will have n minus 1 choices. For the third place, 2 people are used, so I'm gonna have n minus 2 ways. And you can see that the pattern does go on. So let's think about this, how many choices I have for the last place. You can see that for the first n minus 1 places, there are n minus 1 students are chosen. And originally, I have n students, so that means for the last place n, I have only 1 choice. To finish up this question, we just need to multiply every step together, which gave me n times n minus 1 times n minus 2 and until 1. Wait, that looks familiar. Isn't it just n factorial, right? So n factorial would be the number of ways to arrange the n different students. So, in other words, if I have n different elements, the number of ways to arrange the n different elements will just be n factorial. Obviously, the n different elements don't have to be students, right? They can be n different letters, n different numbers, or n different cards. Okay, so now let's have an example to enhance our understanding. This question is asking us how many 5-digit number with repetitive digits can I make by using the numbers 1, 2, 3, 4, 5. Let's have an example. First of all, I need to have 5 digits. So let's draw 5 places first. And the valid 5-digit number for this question will be, let's say, 1, 2, 3, 4, 1. It is okay because it does have repetitive digit, which is 1 and 1. That's basically saying that you can even have something like 1, 1, 1, 1, 1, since it is a 5-digit number first, and it does have repetitive digits. Okay, so here we understand the question, but how do we do it? I want you to pause the video and try to think about this question for a few seconds. And hopefully, well, not hopefully, I think that some of you might be struggling with the question. Because if you want to count the number of such 5-digit numbers directly, you may find it's very challenging. So usually, once you see this kind of situation, you should think of a strategy to not calculate the question directly. Hopefully, you notice the fact that the number of 5-digit numbers with repetitive digit will just equal to the number of total 5-digit number minus the 5-digit number with no repetitive digits. And of course, we're just using the numbers 1, 2, 3, 4, and 5. So that means I don't really need to find this. What I actually need to do is just to find two things. The number of total 5-digit numbers. So that's my first thing. And the second thing will be the number of 5-digit number without repetitive digit. So let's find the number of 5-digit number first. And remember that we're just using the 5 numbers provided. 5 digits, that means 5 places. So I'll draw 5 places first. And of course, I can do this by multiplication principle. Let's choose the digit for the first place first. So I have 5 number choices, so I'm going to have 5 ways to complete my first step. And for the second place, it's still the same, because each place is independent. It doesn't really matter what did I choose before. I'm always welcome to use a number more than once. So my second place, still 5. Same thing for the third place, fourth place, and fifth place. And finally, I just need to multiply all the 5s together, which is just 5 to the power of 5. And remember that our second thing to do will be we need to find a number of 5-digit number without repetitive digits. Notice here, I have 5 numbers and 5 places. So did you find that this is exactly the same as the student's example we just did? Basically, I'm just arranging the 5 numbers. So this time, of course, you can just use multiplication principle. That's our old idea. But now, to be more efficient, we can just apply the formula we just developed, which the answer will just be 5 factorial. So, of course, if you want, you can just try to use multiplication principle to check your answer if it is correct, right? So you have 5 choices for the first place, and for the second place, you're not allowed to use repetitive digits. So I will just have 4 choices here. For the next one, of course, I'm gonna have 3 choices, and 2 choices, and 1 choice. So finally, we just multiply all the numbers together, which just gave me 5 factorial. So don't forget that our answer will be the difference between the 2 cases we just found. So here, I'm gonna use the total 5-digit numbers minus the number of 5-digit numbers without repetitive digits, which is basically 5 to the power of 5 minus 5 factorial. So next time, if you see, let's say you have 5 numbers for 5 places, and each number can only be used once, you can just use a factorial notation. Okay, so now let's look at our second notation, permutation, which is nPr. In the previous section, we know that if we have n different elements, and I have n places for the n elements, so of course, each place is for a unique element. In other words, I'm interested in the number of ways to arrange the n different elements. So of course, I'm gonna have n factorial ways. But this time, I'm gonna make it a little bit different. I'm still gonna have n different elements. But this time, I'm just gonna have r places, which this time, r could be a number that is smaller than n. So r is smaller or equal to n. Of course, if r is a smaller number, I'm not gonna have enough spaces for the n elements. So that means there are some really unlucky elements are not going to be arranged for this time. And there's one more thing I need to point out. In both of the 2 cases, each element will only show up for once. Okay, and now I'm going to point out some vocabulary thing first. It's more like English language thing, like how to call this situation. We know that if we have n elements for n spaces, which is the first case we just talked about, we call this situation a range. But for the second situation, if our place number is smaller or equal to n, this time I'm gonna call it a unit per mute. And hopefully you notice that it says r is smaller or equal to n. So it is really possible that r is just n, which is basically our first case. So you can really say that a range is really a type of way to permute. It's a special case. Oh, we really talk about a lot of conceptual things, so now we are really gonna solve this situation. So same thing here, let's first have some specific examples here. Let's say I have 5 different students, and now I want to pick 3 of them. So not all of them are gonna be arranged. And the 3 lucky students, I'm gonna make a line. I want them to line up. Okay, so of course here I have 3 people, so I'm gonna have 3 places. For the first place, I have 5 students, so that means I'm gonna have 5 choices. I have 5 ways to complete my first step. For the second place, since 1 student is already chosen, so that means I'm gonna have 4 choices this time. So I guess all of you can figure out our third step yourself, which we're gonna have 3 ways. To complete this question, we just simply multiply each step together, which gave me 5 times 4 times 3. And here, there is a really magical thing. If we try to think about this multiplication a little bit, we surprisingly find that this just equal to 5p3. Of course, you can just calculate their values. So let's look at the right side first. According to the permutation formula we learned in the last class, we know 5p3 is just 5 factorial over 5 minus 3 factorial. So that's just 5 factorial over 2 factorial. And remember, when we're dividing the 2 factorials, the thing we do is to expand the factorial. So of course, there's gonna be something to be cancelled out, which just leave me 5 times 4 times 3. That's exactly the same as our left side. So you can see that here I have 5 students. I want to pick 3 of them. I just use 5p3. Is that a coincidence? Well, let's check it in a general case. So this time I'm gonna have n students, and I'm gonna pick r of them to make a line. And we know that n is a number that's greater or equal to r. Same thing here. I need r students. So let's just prepare r spaces. And let's name them 1, 2, 3, 4, and the last one should be r. And let's consider the first place here. I have n students, so I should have n choices here. For the second place, since 1 is chosen, I should have n minus 1 ways. For the third place, so similar thing, right? I should have n minus 2 ways. Okay, and what about the rth place, the last place? Originally, I have n students, and in the previous r minus 1 places here, we know that r minus 1 students are chosen. So that means for the rth place, I'm gonna use my total students number, which is n, minus bracket r minus 1. So, of course, I can open the bracket, which gives me n minus r plus 1. So finally, let's just multiply each step together, which we get n times n minus 1 times n minus 2 until the last one. And don't forget our assumption. In the last example we did, we have 5 students and 3 places, so we have 5p3. This time, I have n students and r places, so reasonably, I will guess that this time my answer will also be nPr. Of course, that's my guess. So now we need to prove this identity here. Still, let's look at the right side. nPr, according to the formula, that will be n factorial over n minus r's factorial. We can use a similar idea. We know that when we're dividing 2 factorial, the best thing we can do is to expand both of the factorials. So based on our experience, all our denominator should be cancelled out. But it's not really clear here. That's because our denominator start with n minus r, but n minus r, obviously, we omit that for the numerator. So a good idea will be, now I can rewrite my numerator in a more comfortable way. This time, I successfully let n minus r to be visible in the numerator. So let's see, this time it's really clear what can be cancelled out, right? Which everything from n minus r to 1 will be gone. And we notice that the things left will be the same as what we want to prove. Okay, so now we can make our conclusion. This time I have an element, and I have r spaces, which could be a smaller number than n. And we also know that each element can only be used once. So in this case, the number of ways to do so will just be nPr. Similarly, let's have an example to reinforce our understanding. This example is asking us how many 3-digit numbers can be made without repetitive digits by using 1, 2, 3, and 4. I'm not sure if you still remember that, but we did exactly the same question before when we were learning multiplication principle. In that time, we got an answer 24. If you want to check that, you can just go back to that video of multiplication principle. But this time, I want you to use the new method we just learned. Now, I have 3 places, and I have 4 different elements, which are 4 different numbers for the 3 places. And each number here will only be used once. So, we know that the answer will just be 4p3. Which you can see here, 4 is the number of different elements, and 3 is how many places I have. To calculate the value of this, we just simply need to use a formula we learned in the last class, which we have 4 factorial over 4 minus 3 factorial. And that does give you 24 as well. Okay, here is our last thing of today, which is combination. And its notation is written as nCr, or you can write as the bracket notation. So, what kind of counting situation is nCr used for? Before this, I want you to rethink our nPr case again, because that will be so related to this one. In the nPr situation, we have n elements, of course they're different. And what we actually did is to try to pick r elements of them, and to arrange these r elements. And according to what we developed, we know that the number of ways for this will just be nPr. But now, let's try to consider this case from another aspect. It seems like I can also complete my mission here by a 2-step process. My step 1 here can just be, we can pick our elements first. And here, what do I mean by pick, or you can say choose, is the only thing I care is who do I have. So their order doesn't really matter. Let's have an example. Let's say I have A, B, C, D, E, there's 5 students. If I want to choose 2 of them, what will be some possibilities? Of course, I can just choose A and B, right? That's a possibility. Another way I can do this is I can choose B and D. However, something to notice here is, if I choose the people B and A, that's not a different possibility. Because if I choose AB or BA, they are all the same persons. Just as what I said here, the only thing important here is who do I have, not the order between the people. So it doesn't really matter if I choose A or B first. They are all the same for me. Okay, so that's my first step, and let's look at our second step. Since originally, I actually want to arrange the R elements. So in my step 2, I should try to arrange these chosen R elements. And now, let's look at each step one by one. For my step 1, seems like now, according to what we have learned yet, there is no way I can solve the number of ways to complete my step 1. So I guess here I'll just denote the number of ways as x. And maybe some days later we are able to solve it. Okay, and let's look at the second step. In the second step, I'm arranging the R elements. Basically saying that I have R places in R elements, so of course, it will be R factorial. So, according to multiplication principle, the total number of ways to complete the whole thing will be x times R factorial. Wait, but one thing we know is the total number of ways also equals to nPr. So that means x times r factorial is just nPr. Since n and r these numbers are given. So if I want, I can solve what x is, which I can just divide by r factorial for both left and right side, which we can easily obtain that x is just nPr over r factorial. Wait, does it seem kind of familiar? If you still remember the formula we talked about in a previous video, you should recognize that this is just nCr, which it can also be written as a bracket notation, which we can call it n choose r. Oh, so here it actually does explain why this is read as n choose r. Remember, what does x mean? X means the number of ways to choose r element from n different elements, which the word choose here indicates that the order between elements doesn't really matter. So the number of ways to do so will just be nCr, or you can say nChooseR. And now let's have a final example to test our skill. In this example, I have 6 students and they will write a final exam. Oh, pretty scary. And there are 3 exam rooms. We can name them A, B, and C for the 6 students. The question is asking us how many ways are there to arrange the 6 students so that room A has 1 student, and room B has 2 students, and the last room C has 3 students. We notice that the number limit for each classroom, they are not random numbers. First room is 1, the second room is 2, and the third room is 3. And when we add 3 numbers together, we get 6, which is exactly the number of students to write the exam. So that means the seats is just enough. There won't be any empty seats. Well, this question actually has a lot of information. So one thing I always recommend you to do is try to list some examples that will definitely help you to understand the question better. Let's name the 6 students 1 to 6. And I'll draw the A, B, C 3 classrooms. So A, it just needs 1 person, so I can just randomly select 1 student for A. For room B, I need 2 students, which I just choose 2 students from the remaining 5. And the last one C, of course, I'm gonna have 3 remaining, which all of them are gonna go to the 3rd classroom. And here, that will be a possible way to complete our mission. And from what we just did, we find that the first thing we do is to choose a student for the first classroom, and then choose for B, and finally for C. And that could be the steps for me to apply the multiplication principle. So my step 1 here, I will just choose 1 student for the room A. Of course, I have 6 people, so I'll just have 6 ways. And now it's the time for the second room. We're gonna choose 2 students for the room B. Originally, I have 6 students, and 1 is chosen for my room A. So now I should have 5 students left. And we're choosing 2 students from these 5 students. So here you can see that we're actually choosing people, which means the order doesn't really matter. The only thing matters here is who do I have, rather than who do I choose first. So, based on what we just learned, I should have 5 choose 2 ways to complete this step. So every time you're confusing, should I use nCr or nPr? Listen, just ask yourself a question. Does the order of the persons I choose matter? So in this case, whether if I choose students 1 and 2 or 2 and 1, of course they are all the same for me. So it tells us we should use nCr. Okay, and we have our last step, which is exactly the same. We're choosing students for the last room C. Originally, I have 6 students, right? And after my first step, 1 student is chosen. So that means I have 5 students left. And after the second step, 2 students are chosen furthermore. So that means I have 5 minus 2, I have 3 students left. And don't forget that for room C, I need exactly 3 students, which I'll just let the 3 students left to go there. I have no choice anymore, right? So that means I have only one way to complete my third step. Well, of course, the choose function in nCr we just learned also works pretty well here. I have 3 people, and I need to choose 3 people, so that's just 3C3, right? And if you calculate that, hopefully you still get 1. Okay, and we have our terminal step. To finish up this question, we just need to multiply every step together, and we should have the first step, which is 6, the second step, 5, choose 2, and the third step, 1. So I just multiply 6 times 5, choose 2, and 1. And if you calculate this, let me see. Hopefully you should get a number 60 as the final answer. Oh, congratulations, you finished one more class here. In this class, we learn how to apply the 3 new operations into a counting question. If you find it is kind of abstract initially, don't give up. Just give more practices. Because once you're getting used to it, you will find that they will really ease your life. And finally, don't forget to subscribe this channel. Bye-bye.